Okay, in our last video, we talked about exponential growth. In this video, we're going to be talking about what happens when a growth cannot grow infinitely without being limited, which is the case with really all organisms on the planet, right? Exponential growth can only last so long, but let's go ahead and look at this exponential growth graph. If you remember, I'm going to draw it very small here. But we had a population that spikes very quickly, right? And then kind of is uninhibited by anything else. That's exponential growth. The growth we're going to be looking at today is called logistic growth. Those of you math people might have seen this before, right? This type of curve, it's called an S curve. The exponential curve is typically called a J curve, right? This is an S curve, is what we're going to be talking about today. If you notice, growth rate starts decreasing once you reach a carrying capacity. This is a word that's going to be fairly important, and we're going to talk about it quite a bit. So you might want to write it to the left of your notes over there. I've also included, just to kind of show you a different type of graph, this is a population graph, and it is a predator-prey relationship. If you'll notice, the mule deer, their population rises, right? As their population rises, what happens to the predator population? Predator population is going to rise. Also, as the predator eats up their food source, that food source drops. And as that food source drops, so does the predator population. So you have this kind of relationship between two curves, predator and prey, in many scenarios. And you'll notice that the predator population always lags a little bit behind. This green lags a little bit behind that prey population. This is just kind of a simple interaction I wanted to show you. Okay, so we are continuing our discussion of population growth. Today we are going to talk about things that limit it. I'm going to put some slideshow mode here. Things that limit population growth. These are called limiting factors. I don't want to use the same words to define it, but it is literally that. Anything that can limit, anything that limits population growth, right? And we typically think of these in two general categories. One of these are density-dependent factors. This means that it is dependent upon the density of an organism. Can you guys think of something so that will limit a population size that is dependent upon the density? I'll pause and let you guys think about that. Okay, so the density of a population can be affected by many things. The first thing most of you maybe thought of, hopefully, is limited resources. Limited resources, right? Not having enough food is going to limit your population growth. They can only grow as long as there's a continual food supply to be harvested, right? Any organism. Okay, so you might have also thought of something like maybe predation. Is this dependent on density? Sure. As we saw in that last slide, as the density of something increases, the predator population will cause that population to decrease, and of course the vice versa that will occur. The prey population will then increase, and the predator population will lag behind again. So these are all density-dependent factors. Also, maybe some of you might have thought of disease, right? This is highly dependent on density of organisms. Okay, let's talk about density-independent factors. These are factors that are, I don't know why I keep crossing stuff out, but independent of density. So density doesn't really matter. We typically think of these as things completely out of the control of anything, right? Earthquakes, tsunamis, random acts, right? Random events, geological events, blah blah blah, all sorts of things. Also, the purposeful burning, right, of the rainforest. I'll just put this again. Amazon rainforest is being burned to the ground. It's being burned. Okay. Of course, humans are in control of this. They are burning the rainforest for profit and money. So hopefully we can, come together and realize that O2 is a little bit more important to us. I'll probably leave this video at this for now. I don't want to go too deep. I don't want to make it too long. The next video we are going to talk about, how this curve looks and some ways to calculate how these limiting factors might affect population growth in a non-exponential situation, which is how most organisms operate. Okay, so on to the next video.